Can I trust Kubernetes for day 2 operations of my business critical Postgres databases? And can I move my Postgres databases from public and proprietary database as a service solutions into Kubernetes? And most importantly, can I do it with near zero cutover time? So these are some of the critical questions that I will address today in my talk, and also discussions here at Kubernetes Community Days in Denmark. So welcome everyone. My name is Gabriele Bartolini, and today I'll introduce you to CloudNativePG, the Kubernetes operator that's transforming how we run Postgres databases in modern cloud-native environment. So before we dive in, a bit of introduction about myself. I've been using Postgres for almost 25 years. I'm a former entrepreneur. I'm a co-founder of Second Quadrant. I don't know how many of you know Second Quadrant? Just only a few of you, okay. So Second Quadrant has been a professional services company operating on the open source Postgres database, and it was acquired by EDB in 2020. And now I'm a VP Chief Architect of Kubernetes at EDB. I'm also a Postgres contributor. I'm also a Data on Kubernetes ambassador. So my mission is to educate and tell everyone that not only is okay to run stateful databases, stateful workloads in Kubernetes, but it's actually a way to innovate in a faster way. I'm a DevOps evangelist. I owe everything to open source and DevOps, and Kubernetes is the produce of my DevOps mindset and culture, and DevOps is also the reason why one day I will probably move away from Kubernetes. I'm an open source contributor. I'm the creator of one of the most popular backup and recovery tools for Postgres called Barman, and also one of the founders of CloudNativePG, which is the reason why I'm here today. So this is briefly the agenda. We'll go through, after an introduction, the past, then the present, and the future of CloudNativePG with some conclusions at the end. So you probably all know Postgres, so I'll just leave this slide. I mean, it's impossible to summarize that in a single slide, but it's 100% open source. It will always be free. And it's the most used and popular database in the world. It owes everything, in my opinion, to its extensibility. You know that Postgres has learned a lot from all the innovations that have come throughout the years. XML, JSON, geospatial data, time series, and also now vector databases. So thanks to extensions, you can plug new data types and new functions similar to Kubernetes, you know, CRDs and controllers, into this engine, very powerful engine. It's got very advanced features. It supports standard SQL and ACID transactions. Some databases are introducing them now. Postgres has had them for almost 30 years. And one of the features that only Postgres has is transactional DDL, which is very useful for the talk that I'll be describing today. So, in terms of operators, I'll be talking about CloudNativePG. CloudNativePG is not the only open source operator for Kubernetes, okay, for Postgres. There are several ones. CloudNativePG started in 2022. I put some of the differences between these operators. In my opinion, of course, you know, I'm biased, but just do it by yourself. My advice is to check them all, check all the licenses, check all the features, but in my opinion, also because we have applied for the sandbox, CNCF sandbox, today, if I had to make a decision, I would go with CloudNativePG. But again, it's all public, it's all transparent, do your own research. Some of the major differentiators are that CloudNativePG is a Kubernetes native operator. It means that it doesn't use an external failover manager. It taught Kubernetes how to handle a primary standby cluster with Postgres. Okay, it doesn't use Patroni, it doesn't use Stolon. Everything is in the Kubernetes API server. And we also directly use PVCs. We don't use stateful sets. Our team is participating in the Kubernetes storage to improve it based on the emerging needs of running databases in Kubernetes. So this is why I think it's a good choice. It's also vendor neutral, so it's the only operator that is not owned by a company. EDB is the creator of this software, but like EDB participates in the development of Postgres, being probably the biggest contributor in Postgres history, we are also the creators of CloudNativePG. Okay, so our mission is to run Postgres everywhere. So the good thing is that with this new operator, many startups are now using Postgres as their database in Kubernetes. And then recently, also this is the number of stars in GitHub, and this is organic growth. We've never had any marketing campaign to influence the growth of popularity in terms of number of stars in GitHub. You can see clearly the trend. Who was last week in Salt Lake? I advise to go and watch the video that Peter Zaitsev gave, the talk that he gave about an overview of Postgres operators, and he clearly said that CloudNativePG is kicking everyone's bum. He didn't say bum, but just look about that overview that he gave. So it's used in production by EDB, by IBM, Google, Azure, Tembo, and I also learned last week Akamai is using it in production. As I said before, we applied for the sandbox, and it can be installed in multiple ways as Kubernetes manifest, Helm charts, also OLM, 3,600 commits, 4.7 thousand stars, and 60 million downloads in 2 years. Of course, it doesn't mean that there's people that manually download it. It means that it's used in CI/CD pipelines, which is very important for the rest of the talk. So let's start with the past. Everyone remembers this. Okay, every time I meet Kelsey, I say, look, you've ruined my life. You have no idea how difficult you've made it. Because every time I talk to some of you, you tell me that you're all scared to run databases in Kubernetes, and that's because of this. But this is the evolution, okay? It all started like this. Kubernetes, was initially born to address stateless workloads, okay? But then, of course, it evolved. So here you find a bit of history about Postgres in containers. So the operator pattern was released in November 2016. Then I think Crunchy was the first operator in March 2017, followed by Zalando in 2018. Then I think what caught our attention was in Kubernetes 1.14, the release of local persistent volumes. So that's when we started to say, hang on, this is an important feature. We cannot ignore Kubernetes anymore. And that's when my former co-founder, Simon Riggs, who unfortunately passed away a few months ago, is probably the biggest contributor to Postgres enterprise features ever, okay? So he told me, Gabriele, go and start this initiative at second quadrant to bring Postgres into Kubernetes. And we approached it with a fail-fast methodology, so we wanted to see if the investment was worth. So what we did, we set up a Kubernetes bare metal cluster in Hetzner, and we ran benchmarks first on Postgres on bare metal, and then Postgres inside Kubernetes on bare metal. And we saw that the penalty was very minimal. Actually wrote a blog post about that. It became viral, and that's when the whole data on Kubernetes community started, and so on. So EDB launched the proprietary product in 2021, and we open sourced it in Valencia for KubeCon Europe in May 2022. And we submitted it a first time to the CNCF sandbox. It was rejected, but we tried again in September, and by January, we hope we have an answer. And in October, we've become the most popular operator for Postgres. So when you look at the evolution of Postgres, you have to think about the 90s, where everything was bare metal, on-prem. Then VMs came out, and everyone said, you're crazy if you run Postgres in a VM. Okay, like, you know, we hear it now. You're crazy if you run it in Kubernetes, okay? Then, you know, the cloud came, and it was primarily infrastructure as service and covering day one operations. Then the need of day two operations arise, and that's when DBaaS started to become popular. And now I think it's the time to reach cloud neutrality with Postgres and Kubernetes with CloudNativePG. Okay, we have an opportunity now to run day two operations with an operator. However, what I see very often now, and even when I talk with Kubernetes offering services, Kubernetes organizations that offer services, they tell me that they prefer to keep the database outside Kubernetes. How many of you are in this use case, that they keep it outside Kubernetes? Okay. So I think the reason, when I talk to these people, they always tell me, because it's day two operation, I don't have to worry about backups, I don't have to worry about self-healing, high availability, and so on, okay? Which is fine, okay? But we'll see what we're missing, okay? So right now, the situation has changed. This is my friend Michelle Au from Google. I gave a talk with her last year in Chicago about disaster recovery of very large databases in Kubernetes. We proved how to restore a 4.5 terabyte Postgres database in 2 minutes, thanks to volume snapshots, okay? So Michelle says that now we can run petabytes databases in Kubernetes, like, you know, it's a normal thing. Or this is Piotr from IBM, who I think he gave this statement in one of the panels we ran at EDB. IBM Cloud Pak has chosen our operator to run their databases for Postgres, pretty much in all IBM Cloud Pak solutions. So it's production ready. And if you want to know more, this is a blog article I wrote a few months ago that I think provides a summary of the last 10 years of Kubernetes, actually the first 10 years of Kubernetes, and the last in terms of Postgres adoption in Kubernetes. And last week, I was at KubeCon in Salt Lake, and I was part of that panel with Melissa Logan, Deepti from PlanetScale, and Sergey from Percona about the future of DBaaS. So if you want, you can scan that QR code here. But we released as Data on Kubernetes community a report about the usage of state workloads and in Kubernetes. And databases are the #1 workload in Kubernetes, followed by AI. So AI is actually becoming more popular, but what it does, because AI requires data, it's actually accelerating the adoption of databases inside Kubernetes. So the opportunity we have now is to build what I call cloud-neutral Postgres. So instead of cloud-native Postgres, cloud-neutral Postgres. So we can achieve neutrality with the CloudNativePG stack. So CloudNativePG stack is Kubernetes, Postgres, and the CloudNativePG operator, and the components that are part of the ecosystem of CloudNativePG. So what we can do, thanks to Kubernetes, is to achieve neutrality in terms of infrastructure and applications. And Postgres is an application in Kubernetes' mind, a special application, but it's an application. So what we can do is something unprecedented. We can use the same stack and deploy it everywhere, private, public, hybrid, and multi-cloud. Okay? And what we see is a return on on-prem deployments. Okay, we can use bare metal nodes to run Postgres. You can think this could be an anti-pattern, but it's actually a very good way to achieve optimization of costs. And also, what I say after is you can actually migrate VMs into bare metal Kubernetes and save costs on licenses. So the most common use case right now for CloudNativePG is what I call an internal or external DBaaS. Think about, for example, Tembo is a organization that provides external DBaaS solutions for their customers based on Kubernetes and CloudNativePG. But most organizations, they have kind of a dev and ops situation, not DevOps, but separated silos, and they provide services, database services to their application developers. So this is kind of an internal DBaaS solution, okay? So what you can do with CloudNativePG is you can extend to day two operations the Postgres database within your organization. And you can also implement GitOps and infrastructure as code for your Postgres databases. Also, we are in Europe. It's important that, to know that there's a European Act that started this year, and it requires data portability. You can use, with CloudNativePG, you can take advantage of the native streaming replication feature to basically synchronize the state of Postgres databases everywhere. So you can easily achieve hybrid and multi-cloud with this solution without changing, only changing maybe the storage class. That's all you have to do. So is it cattle versus pets? What I say is actually cattle, pets, and elephants. So Postgres is an elephant, so it needs to be treated a bit specially, okay? So it's not like pets, but it's more like cattle, but it's neither of them, okay? You need to treat it a bit specially, but the way you do it resonates with both infrastructure people and DBAs. So essentially, we can take advantage of bare metal nodes, for example, or even local storage, if you want to, and then use taints and tolerations to operate on the logical level. So you separate physical and logical deployment very easily through infrastructure as code. So you can implement what we call shared nothing architectures for databases. They're very popular, and they're the best way to run databases nowadays. And so if you isolate Postgres workloads, you get the best performance results. And last, you free yourself from any form of vendor lock-in. This is again a recap of the opportunity we have to use bare metal nodes just for Postgres. Okay, it's much, much faster, and we can, if we want, use local storage. So some of the main features of CloudNativePG, I mean, this is just for the sake of completeness. You know, I won't go through all of them, but it's, I mean, we take for granted that self-healing and high availability are achieved. And we do it through native streaming replication, physical streaming replication. We don't use storage replication with Postgres. We just rely on this native replication of Postgres, which supports synchronous replication at transaction level. Postgres comes with continuous backup, so basically you can achieve point-in-time recovery. You can restore at any point in time with Postgres without taking, you know, backups every hour or so, okay? Just take one a day, and then you store the whole files, and you cover it. This is for business continuity. Imagine that Postgres has been running for many, many years in business and mission-critical environments. All of that is now into Kubernetes. Security by default is another of my favorite. I mean, I put a simple patch in Postgres 17 that disables alter system in Postgres. So you cannot, there's a configuration that prevents you from changing parameters of Postgres on the fly, okay, because we want to go through GitOps. Okay, there's no super user access by default with our operator. If you want to change parameters, you go through the manifest. Another, and I will stop here, the replica cluster is the possibility to have clusters, for example, in another region or another Kubernetes cluster. This is a recap of the cluster resource. It's very simple. We adopt convention over configuration. So in this case, I asked to create the Clapton cluster with 3 instances, put the workloads on Postgres nodes, have a synchronous replication with quorum on 1, have a volume of 10 gigabytes and one for PG data of 40 gigabytes. And what happens is this. You have your Kubernetes cluster with your nodes. The operator creates the PVCs, starts the primary pod. The read-write service is set so the applications can start writing. And then we create the replicas, and we set the read-only service. So what happens if there's a problem on the primary node? The operator immediately detects that with readiness probes, and this detaches the read-write service, promotes the standby, and if the former primary comes back again, it's demoted to a standby. So what we see now is this. Okay, you have your applications in a namespace in Kubernetes, and your Postgres database is in either another Kubernetes cluster or namespace. And this is just to let you know that it's possible to have architectures that span across multiple Kubernetes clusters. I won't go through these in detail, but if you want, we can talk later. And if you want to read, there's this blog article I wrote for the CNCF last year that covers all these architectures. So the future is what we call microservice database. If you want to know more, again, this is a blog article I wrote. And this is what we think we should go. So very few people are doing this. But we believe that if application developers understand that they can own the database, and they can put the database as part of their CI/CD pipelines, they will innovate faster. So this is an example. You are a developer. In lean methodologies and lean culture, you have to think always about the customer, the end user. So you need to create a sort of highway between you and the end user. You write code for your application, a new feature. You can use kind locally to test your feature with Postgres. Database change management, you need to test it. Test that it works. If it works, you issue PR. The PR, so this is the DevOps capabilities in orange. This is version control. You issue, you start automated tests. So test automation, and shift left on security if you also do code scanning and container image scanning before you build them. Okay? Then you build your container images. You use those container images to test, using end-to-end test. And again, you use kind with Postgres to test everything works. And that's where you test your database change management, the migrations. And here you can use imperative ones, so you place the changes in your code like alter table and so on, or use tools like Atlas that allow you to do it in a declarative way, and they perform the differences between them. And then you're in continuous delivery because everything passes, you merge on main, you adopt trunk-based development, and then based on a release policy, you publish the container images in production and you deploy. Where do you deploy? On Kubernetes, so no variability between the local environment and the production one. And that's how you achieve 10, 20, 50 releases per day in an automated fashion. Okay, so this is the opportunity. And here you have the first feedback loop here and the second feedback loop here. So this is about empowering application developers to increase velocity of their features. So the future sandbox. Here you can find our public application. If you use CloudNativePG, I'm asking you to go there and please, say that you like it and you think that it's good if this project gets accepted in the CNCF sandbox. And of course, participate. Then in terms of roadmap, we are adding the declarative database management, so you can create your own database resources. Then logical replication is a way for you, for example, to move from RDS into CloudNativePG through a subscription. You can do it in a declarative way with zero cutover downtime. Get zero cutover time. Then also the role resource, we are working on that. We already have introduced spread rolling upgrades. So if you have 100 clusters and you upgrade the operator, you can say, wait 1 minute between cluster upgrades. The most important feature we're working on is the interface. So CNPGI allows us to extend the operator through plugins. The first one will be a Barman Cloud plugin. So we remove Barman Cloud from the operator source code and we put it as a plugin. Then we are working with Kubernetes storage for volume group snapshot support. And also we are working with Kubernetes to improve support for extensions. We want to load them on the fly as immutable containers. So we are changing the way Postgres works as well as Kubernetes works to achieve immutability in terms of extensions. And then major upgrades in a declarative fashion. So to conclude, I want to enforce about the people, okay? So we think that, it's easy to run anything today, okay? I mean, that's an illusion, okay? We manage complex infrastructures. So we need people, we need skills, we need you to come to these conferences and understand what we do. So there's a great book by Gene Kim and Stephen Spears called Wiring the Winning Organization. They stress about the social circuitry, that's what they call leadership, focus on the people, on empowering people to solidify, simplify, and amplify the concepts we talk about. So we've gone through these phases. Sorry, I pressed the wrong. So first, everything was on bare metal in Postgres. Then VMs came, and I think now we're in the phase to start another S-curve with Postgres thanks to Kubernetes. And this is again, the exercise we need to do when we work with Postgres in Kubernetes. Okay, it's not pets, it's not cattle, it's a bit different. The difference is on choosing the storage and the nodes you work on, isolating the workloads. So the key takeaways for today, so don't be afraid to run stateful workloads in Kubernetes. And Postgres is the most popular database. My advice is to try it before you go with something else, because it's extensible. And CNPG now is the most popular operator for Postgres. With CloudNativePG, we are still in the first phase of adoption, which is primarily the DBaaS use case. But as I introduced today, I think we have an opportunity for the second phase to address the microservice database. And already we can achieve cloud neutrality. So this is important. Free yourself from any vendor lock-in. And again, focus on people and outcomes more than technologies. Okay, but you need leadership for this. Okay, and I want to thank all the maintainers of CloudNativePG and also EDB for donating the IP, the intellectual property of the operator to the community so that it can be taken by the CNCF, hopefully. And this is a reminder, of the virtuous cycle of open source software. There's organizations like EDB that contribute to open source software. There's a community and users, and please support any organization that writes open source software. So I'm done. So if you have any questions, more than happy to answer.
Thank you. Thank you, Gab. This is little gift to you. Thank you. Thank you. Do we have any questions? Okay. Which one first? It doesn't matter. I'll get to you. We have 4.5 minutes.
Yes. Database administrators usually take care of a lot of this on VM, so you have kind of expropriated all of that responsibility to other people. Do you see that CloudNativePG is kind of taking that responsibility back, and you also have to have the cognitive load of being a database administrator, or is it taking care of it for you?
Okay, thanks for the question. So first phase of CloudNativePG was to bring Postgres to Kubernetes. Okay, we thought that we had to adopt the Kubernetes mindset first. That's why it resonates a lot with Kubernetes people. Now, the second phase of that educational side of things has started. And now, for example, I've been away from Postgres conferences for 5 years, and I've resumed now, because I think now it's mature for us to talk to DBAs, Postgres DBAs, that so far have never even opened the door of Kubernetes, okay? But now we talk to them and actually see that everything resonates. When they see what the operations that the operator does, they say, wow, I mean, this is amazing. And they understand. So we need both, because right now, most of Kubernetes people that use the operator don't know anything about Postgres, and that can be dangerous, okay? What we did now is to get on board all these Postgres expertise into Kubernetes so that we can push forward Kubernetes. So they're a bit afraid. There's job security dynamics that come into play, but we are trying to address them. So we are trying now to be more present in the Postgres community. But I've seen it work. I mean, if they understand how Kubernetes works, and it normally takes a month and a half, 1 hour a day, you follow Mumshad, Manambeth course, and you're done. Okay, they understand enough Kubernetes to build a T-shaped profile. They don't need to be experts. They need to know enough Kubernetes to talk with infrastructure people. And infrastructure people need to know enough databases to talk with these people. So we need multidisciplinary teams. And to go back to the application value stream, in team topologies, they're called stream-aligned teams. We often talk about platform teams, but the stream-aligned teams are the ones that take value to the customer, okay? And the opportunity here is to bring the DBAs into that team and achieve high velocity of your applications with Postgres expertise. So their profession is elevated. They don't do any more the boring stuff, but they need to understand what happens in case of problems, and they can help you address, for example, scalability of issues in the database with indexes and so on, help you draft the models, and help you read the logs of Postgres. Okay, so did I answer? Thank you.
Yeah, just a quick follow-up on what you said, that we hired a DBA. During recruitment, we asked him to set up Postgres on VMs, and then when he worked with us, he set it up on Kubernetes. There's no problem with job security. There's so much stuff that Postgres can do, and like you said, they just elevate the level. Now to my extra question. I was wondering, what are the main blockers towards accepting CloudNativePG as a sandbox project in CNCF? You mentioned in some slide it was the second attempt?
Yes, so in July 2022 it was rejected because our submission was interpreted as a kingmaker process. So the CNCF at the time the TOC didn't want to choose an operator. I didn't agree with that decision because our operator was the only community project. But we accepted it and we said, okay, let's see how we continue doing our job. And clearly you see the adoption. I mean, now I think it's more difficult to reject our project, okay? But this is my last attempt, okay? So I will accept it and I won't, submit it again, so.
Thank you and fingers crossed.
Yeah, thanks. And if you use it again, please go there, put a thumbs up or...
Yes. If you have further questions, I would suggest go out and visit the EDB booth. I hope Gab will be there to answer questions.
I'll be there.
Yes.
I'll be there.
All right. Thanks. Thank you. Please give a round of applause to Gab.
Thank you. It's been and thanks for the organizers.
Thank you. And please remember to rate.